Hi everyone, welcome back to my channel Ex.13.1 Permutation and combination from the chapter 13 from the advanced book. We have three exercises, exercise 13.1, 13.2 and 13.3. 13.1 is basically about the basic counting principle. 13.1 is about the permutation and 13.2 is about the combination. Remember, the 13.1 is not the permutation or the combination. This is just to learn this what do you mean by basic counting principle, which will be used in 13.2 permutation and 13.2 combination. So basic counting principle, I would like to explain you for 13.1. The basic counting principle means we need the total outcomes because the total outcomes are very important for any of the permutation or the combination. So total outcomes means I would like to give an example of a dice. No, dice is better. I think so. I will use a coin. When you have a coin, normally how many sample space are there for a coin? When you toss a coin can have the sample space about head or tail. And I'm talking about the fair coin, not in the vertical position. It is always like head or the tail. So unbiased or fair coin means head or tail. There are two number of sample space. This is very simple to have the like a coin and the number of sample space are two. But when we are having two coins, this is the actually the topic, the basic counting principle. When we have two coins, it means the first coin can have I can write the head, tail, and the second coin can also have the same thing, head and tail. So there are so many possibilities. You can have, for example, we can draw a box. This is only the explanation. This I would like to explain you what is basic counting principle. For example, normally we use is the probability. For example, there is nothing here. This is coin one and this is coin two. The coin two is head tail here and coin one head tail is I'm writing here. And when you have when you toss two coins, it is possible that you can have two head together, two tail together, one head, one tail, or one tail, one head. So the outcomes are here. I'm writing from head and head is coming head, head. Like I can write here is from the white coin one head, first head here, tail here. But when we use from here, it's coming head. From here is coming tail, from here is coming head, and from here is coming tail. So these are the outcomes. We have like number of sample space are 4 because only 4 are possible. When you have a dice, for example, for a dice you can have in a dice you have 1, 2, 3, 4, 5, and 6. So when you have 1, 2, 3, 4, 5, 6, and the other dice is also unbiased, means fair 1, 2, 3, 4, 5, and 6. So what you will do? How can you make when you throw two dice? It can be 1, 1, it can be 1, 1, it can be 1, 2, it can be 1, 3, it can be 1, 4, it can be 1, 5, it can be 1, 6, or it can be 2, 1, 2, 2. Like there are so many sample space. So what is basic counting principle? The basic counting principle says whenever you have individual number of sample space is 6 and 6, or here 2, or here is 2. What do you have to do? Just 2 and 2 should multiply. It's coming what? 4. This 6 and 6 when you multiply is coming what? 36. This is called the basic counting principle. When you have the individual outcomes and to multiply all the outcomes, you will get the total outcomes by using all the event. You have dice or coins. Suppose we have three coins. Three coins means the first coin have two sample space, second have two and third is also have two individually. So we just need to multiply and get is equals to, there are eight possible outcomes. And eight possible outcomes mean it can be 1, 1, 1, it can be 1, 1, 2, it can be 1, 2, 1, it can be 1, 2. Like this way we can make actually eight outcomes. So this is the main theme for our exercise 13.1. one, which is basic counting principles. Let's start with question number one. When you say question number one, here is given a coin has tossed three times. So it means like I have to write 2 into 2 into 2 and it's coming 8. Normally the teacher said just write 2 cube is equals to 8. Okay, it's okay, but this is my method is what is normally we multiply the individual like outcomes and get the total outcomes. So three outcomes and I don't need to draw here uh, we find the possible outcomes we have done. There is no problem. And the tree diagram is basically what, and we don't need a tree diagram here. This is for actually O levels math. This is the first uh, coin. Second coin with head and tail that are possible like here. The second coin. The third coin with this two, with this two, with this two, and with this two. You can check 1, 2, 3, 4, 5, 6, 7, 8. There are 8 outcomes. Like head, tail, this will be head, 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 head. The first outcome. Head, and tail is here. This is the way actually we like, and you can make the tree diagram, and we don't need tree diagram for ATMAS actually for this topic. So once again, I'm telling you this 13.1 is only used to help 13.2 and 13.3. Main exercise is 13.2 and 3, not 13.1, just to learn basic counting principle. You can see in question number 2, a quiz topic like 5 multiple choices. There are 5 multiple choices. Each question has 4 choices. Okay, and how many like totally unfamiliar with the topic on like if you have first question and you are about the question is not in China in Chinese language and you have 4 options and you are not familiar, so whatever you can write A, you can write B, you can write C, or you can write D. And like each question is having 4 like possibilities. So first question has 4, second question has 4, third question has 4, fourth question has 4, and fifth question is also having 4. Teachers normally write 5, 4 power 5, but how you can get 5 actually? Why we are having 5 in the power? No, there are each question has 4 outcomes. First question is 4 outcomes, second question is 4 outcomes. So just this answer is coming 1, 0, 2, 4, and that's very simple. In question number 3, there are 3 feeder versus okay, link to and from the okay. Joy can ride one of these service walk to the town. However, he decide okay, he has three. We have 3 bus services, and even he can walk. Like there are 4 possibilities here altogether. Okay, he can walk. But when he's going to, however, he decided when he come back to, he will ride on 3 services. Like he is going when he's coming back, he will not walk. He will use only 3. Like so, it means what is simple. When he's going, he has 4 options. When he's coming, is having 3 options. Going like going to the town, he has 3 options. Or going to town center is 4 options. He can use like 3 buses, or he can walk. 4 options. But when he's coming back, he doesn't want to come with like on foot. So it means coming back 3 options. Answer is coming 12. Even if we can check the answer is coming exactly 12. So, like, this was very simple, basic counting principle. I'm just moving. I want to do all these like questions little fast because this main exercise is 13.2. Find the number of people who arrange, like ways to arrange. Okay, we have to arrange. Very simple. Normally, this can help us in permutation or in combination. What we can do, uh, we have to arrange these people in this way. For example, there are 5 positions and 5 people. When I have the first chance, I can have how many people are possible to put here? I have 5 options. Like I have 5 persons and person A, person B, person C, person D, and person E. All 5 like I can put A, I can put B or C, like 5 options. But when I have one person fixed here, fixed, it can be anyone. It can be C. So then I have only 4 options here. Then I have 3 options here. Then I have 2 options, then 1. This is actually when we multiply because each step when I want to arrange someone, so is called normally teacher said use 5 factorial. The 5 factorial means we are moving like 5, 4, 3, 2 until 1. This is called the 5 factorial. This is the easiest way, or you can just write 5 times 20, then you can multiply. So it's coming, I think so, it's coming 120. You can use calculator. It's very simple. Next part, uh, Clara has to do following during the lunch break or lunch break. How many things uh, she has take lunch, post a letter, go to the bank and buy an afternoon paper. So in how many ways can he do all these? How many ways? So actually she has to do 4 tasks. In the first task she can do anything. She can take lunch. It's up to her. So 4 into like when she has done 1 task, then how many tasks are left? 3. Then she has 3 like 1 task more than 2 and then 1. This is called the 4 factorial and you can have the answer like 312 and is coming 24 I think so. And this 120. Do we have the second part? Oh, yeah, sorry. This 24 is coming. And so is coming 24. And we have the B part here. We left here, sorry. The B part is 6 people. I will write 6 factorial. And 6 factorial will be definitely have to check is coming 720. Very simple. So once again, I'm telling you, I'm just doing the basic counting principle, not the permutation or the combination. So in question number 6, you can see there are 6 men and 5 women, and we have to make the double like pair next. So it's very simple. What we need, the men are 6 and women are 5, just coming 30. That's it. Because individual outcomes like men are 6 and women are 5, so we can. 3 friends decide to have dinner together and then go to the shopping. This is second part 7. 5 restaurant are there and dinner and 4 nearby shopping centers. Now, how many possibilities are there? So very simple. Restaurants are 5 and shopping possibilities are 4. So it's coming 20 and that's very simple. A big company classify its employee according to the sex. Like sex, we can have male or female. There are 2 possibilities. Age groups are already 6 here. And the employees types are 10 categories. So very simple. How many classifications there? 2 multiplied by 6 multiplied by 10 is coming 120. I'm not doing the next questions for very simple because main target is to start 13.2, which is permutation. So let's see. I hope this basic counting principle will definitely help you with how we can why we multiply the outcomes. I have told you to get the total outcome. So once again, thank you so much and have a nice day.